Hi everyone, my name is Monique Casanova and welcome to What's the Scope? This is a new initiative for students hosted by Eastern Engineering Group where students get to pick out a structure that they admire in Miami and we contact the design team to see if they're willing to give us an interview and answer all of our design and technical questions. Today we are going to be talking about the Phillip and Patricia Frost Museum of Science, this amazing and unique structure that is not only beautiful, but is a green building. It won the LEED Gold certificate last year, and we were just very excited. We're talking to Grimshaw Architects today, and then next week we're going to be talking to DDA engineers. We got some pretty cool answers today. We had some technical difficulties as well, but I think you shouldn't miss it and check it out. So now that we're all together, Erin, this is Stephanie, my name is Monique, and I'm just going to start the meeting. I'm just going to give a little bit of an introduction about everybody. So Erin and Christian, first of all, on behalf of Stephanie and everybody at Eastern Engineering Group, we want to thank you so much for taking the time out of your schedule to meet with us. We are very excited to talk about the Phillip and Patricia Frost Museum of Science. And just to give a mini introduction of the firm, Grimshaw Architects is a multinational architectural firm founding in 1980 in London, and they have offices worldwide. The firm has performed amazing, innovative designs in several continents, but what I think is very awesome is that they always keep in mind the principles of humane, enduring, and sustainable designs. We're going to be talking with Erin, Vaden-Youmans, which you're in LA, and then Christian Hoenigschmid in London. I'm so sorry if I mispronounced them. And I introduced you to Stephanie Fernandez. She used to be an intern with us in the fall of 2019. And do you want to give a little introduction of yourself, Stephanie?
Yeah, hi, good afternoon. Thank you for taking your time to meet with us and answer some questions about the Museum of Science. My name is Stephanie Fernandez, and I'm currently a junior studying civil engineering at Florida International University in Miami. And I'm excited to know more about the museum because there's much more to it than you just see on the surface. So whenever you guys are ready, we can start the questions.
Ready as you can get it.
You know,
okay.
Did Christian already tell you that he worked on the project since what year? Christian, was that
2007?
Yeah. So
when we since we won the project.
It was.
Wow.
No, we haven't. Sorry, no, Erin, we have not talked about the project at all.
Okay, I just wanted to share with you because sometimes you it's hard to know how long some of these things last, but it was a very long engagement.
Yeah, it was 2 months shy of 10 years.
Oh wow, that's a long time.
And
because I saw on the website that the construction was done in 2017, correct?
So groundbreaking was in 2012, February of 2012, and then it opened in May 2017, correct?
Well, yeah, no, that is very long.
Wow, yeah, I had no idea.
Construction took a bit longer than anticipated, but also the design phase took longer.
And
okay.
And sometimes it's worth just the other key piece of context is that for Grimshaw Architects anyway, we had in our case we had a project manager who Christian was running the project more or less for that time period. Meaning, what would you say about 90% of your time over that period? Almost, maybe averaging out about 90% of your time was spent on the Miami Science Museum.
Yes, yeah.
It's quite an intimate appreciation that Christian has both for the Science Museum and for the city of Miami, for that matter. So, some practices don't work that way. Sometimes you have a project manager who moves with like they'll always just do a certain design phase and just move along. At Grimshaw, and this is the only thing I'll say, and then I'm going to shut up.
No, please keep going.
No, yeah.
Christian may not want to say this because sometimes you need someone else to say this about you, but Christian was dedicated to that project for a lot longer time than a lot of architects find themselves connected to a project, and I just wanted to share that. Christian actually hired me to help him on the Science Museum And we worked on it for many years together until I moved out to LA. So I'll leave it there.
Oh, wow. I mean, you kind of answered like one of my questions, because we wanted to know about like the design process and the approach you guys take at Grimshaw and how it differs between like locations and different projects. So that kind of like answered something.
Well, the design process doesn't differ based on the location. The design process is quite often similar, but it's one of the drivers is the location. It's the program of the building, it's the location of the building, and it's, as most of our projects are for public institutions or transport buildings, right? I.e., where a large number of the public passes through or comes to as a destination. It's also all of our projects also have the visitor, the user in mind, right? So hence the tools we use are sort of similar from project to project, but the outcome then can look very different, right? In sense of the massing of the building, what materiality is used, how transparent, how solid it is. But it tries to be. It tries to be contextual. It tries to be sustainable. It tries to be a clear response to the program, right? So very much driven by what the client wants and needs, sometimes without knowing it. And then ideally to create a unique space for the user. May this be, in this case, a visitor who's coming to the museum, or in case of a train station, the person who's passing through this building.
Right. So did you guys always have this location in mind for the project, like from the start, or was there another location in mind? Because there was the old museum.
The location was set through the master plan.
Okay.
There was a master plan done, I think that probably dates back to, as I mentioned, we won the competition in 2007. The master plan might date back a year or two earlier, done by Cooper Robertson, that redesigned this whole museum park, right? This was somewhat of a leftover green area, had fallen a little bit into disrepair. Homeless people sort of used it. So it wasn't really sort of in the zone of awareness of people in Miami. Just north of the Metro Movie, you had the Performing Arts Center, the tall towers, the residential towers. They were just starting to get built, right? Zahadid Tower was yet to come. And then the master plan placed the two museums on the north end, with a plaza in between, and then the park to the south. So the art museum had the already defined location, and the science museum had a defined location. And with those locations, then they did two independent design competitions.
Oh, okay.
And we only went for the one of the science museum, which we then won. And the art museum was done by Herzog and de Meuron.
Oh, okay. So were there any like design aspects that you took from like the old museum that was like in Vizcaya?
Yes. Well, yes and no. I mean, it was a building that was cherished by the community. They had galleries. Right? So the key components of the existing museum was galleries, was a wildlife center with an indoor and an outdoor component, where they also had an animal clinic and a rehabilitation center for birds of prey. And then on the other end, the planetarium, right, clearly expressed with as a sort of semi-sphere.
Right.
So the program, in principle, was similar, just pimped up, right? So it was again a quite diverse building program of galleries with permanent and temporary exhibits. Something that is now called just an aquarium. For long term, it was called the living core. So it was a combination of aquatic and terrestrial habitats for species that are are sort of a cross section from inner Florida going out to the Gulf Stream, and again a planetarium, right? But again, the planetarium now is sort of state of the art, right?
Yeah.
While the planetarium at the old museum was maybe state of the art when it was built in the 60s, I think, right? But it didn't have any more an up-to-date projection system. The sound system wasn't great, right? So it was more about the components and the program that the museum had, with also a strong a community outreach aspect that they wanted to maintain. So it was more about those aspects than necessarily than architectural cues from the existing building that we took over.
Right. I hadn't been to the old museum in a very long time, but I know that I also went to the new one, I think a month after it opened in 2017. But the designs are completely different. Where did you guys get the design to do? The old one was the half dome shape for the planetarium. Where did you guys get the idea to do like a full sphere for the new one? Have you ever done one like that before?
Just for the planetarium, the design idea.
Yeah.
So we have done we did a planetarium before, not of that size and not in this expressive shape. The reason why it is expressed as the shape as it is, was not really linked to the fact that the existing museum had the planetarium visible. I mean, most science museums or science centers who have a planetarium, who have an IMAX theater, it is somewhat expressed within the architecture, right? So this is actually something quite common. One of the key drivers for this project was to, and this sort of falls into a larger sustainability agenda that Aaron can maybe expand on, is to have as much of the building program in the exterior. So the initial building program that we received as a brief had, for each interior gallery component, an exterior component. They wanted to have a lot of exhibition spaces and a good portion of the aquarium, of the living core, in the exterior, right? So in order to create a comfortable environment in the exterior, right, in Miami, right, which can get hot and quite stuffy, quite right humid, right? How do you create this without either right, blasting air condition from the interior spaces into exterior spaces, or having fans everywhere to create air movement, right? So we did this by using the prevailing winds that pretty much pass across the site throughout the year from the southeast, right? So they come, so the location of the museum by chance is perfect because it's in straight line of Governor's Cut, right? So you have, though it is not right out on the in Miami Beach, right? So right on the ocean front, but it's off the bay. As you have Governor's Cut, you still have those winds that come across the Atlantic, pretty much unobstructed, undisturbed, hitting the site. And you have this almost year round, right? At regular wind speeds. So if you create a building shape that sort of opens itself to the wind and lets the wind flow through, right? You can increase visitor comfort, right? If you are in a hot, humid climate, right? As long as you're out of the sun and you feel somewhat of a breeze, right? And the heat is sort of taken off your body, right? You're cooling down, and it's actually comfortable. So the combination of this very diverse building program and the desire to open to harness the wind and to create a comfortable environment for as much of the building program as possible in the exterior, the outcome of combining those two initial drivers, the program and the driver, was to create not one building, but sort of a campus of buildings, right? So it's a very unusual building. It doesn't have a front door, right? You go into this canyon, and from there, you go into the individual buildings, right? One of those 4 buildings is the planetarium that sits sort of at a knuckle, at a pivot location within the plan. So there are these 2 wings that, or bar buildings, as we call them, that sort of branch out to either side from the planetarium. And these sort of 3 buildings form sort of like an opening stance within which then the living core nestles, right? But in general, this building, the configuration of the buildings open themselves up to this breeze coming in from the ocean, right? So we also knew we wanted to express the planetarium, right, as a shape. In the beginning, we weren't sure if it's a full sphere, half a dome, if you do it as a cylinder, etc., etc. But we knew we wanted to express it somewhere. And there are tons of iteration, and it kept moving around within the footprint of the building. Mm-hmm. But it was always clearly expressed as an own volume. And then at some point, it's moved into this building corner and sort of provided sort of the how do you say this? The transition between the two directions of the bar buildings, right?
Right.
And then I think with moving it into this location and moving the other buildings sort of away from it, so clearly giving the planetarium its space, right? We then also said we express it as a full sphere, right? Because the planetarium has the screen within the planetarium is a true hemisphere, right? Mm-hmm. Half a sphere, right? But technically, all the audience seating is below, right? And you technically can continue this shape further, right? So so there was the architectural intention to express it as much as possible, as it sort of sits on this sort of plinth as a sphere, and then structurally it works as a full sphere, right? So there is a benefit in doing it as a sphere rather than as a half a sphere, and then and have that sit on a different geometry. So there also there were architectural benefits. Well, there was an architectural desire, and there were structural benefits to do so. And this is sort of typical for a lot of the results in our design process. It's not just a design idea, right? Mm-hmm. I want this to look like a sphere, right? There are multiple reasons why that is. And they can be architectural, they can be structural, they can be environmental, mm-hmm. right? Which is also, if you look back, there are tons of iterations of our projects, and they keep looking very different along these stages, sometimes actually very awkward. And it takes quite a while to get that right, because we want the shapes and the components have a true reason and a purpose, and not just be of a certain shape because one of the architects on the project liked that shape.
Yeah, right.
Do you, sorry, Aaron, I've been talking all the time. Do you want to add anything on the planetarium, or maybe general sort of just on this idea of harnessing the wind, on how this ties into sort of an overall sustainability agenda?
Just to say that the proposing that and then achieving that are there's quite a bit of intervening work that of course had to be done, right? Because you have a lot of stakeholders in a museum that you must convince that you're creating a place which is, you might say, resilient to changing perceptions of the environment, different demographics, who's comfortable in a non-conditioned space. Will you have the visitor flow? Will you have the same number of people coming if they perceive that, it's going to be a rainy day, I may not want to come. So, and of course, as architects, you have to manage all those stakeholders effectively. You have to, and you don't always have a lot of time to make that case. So, and I think, Christian can share more of the detail because he was in those conversations. I was just listening to the results. But often we'd be provoked. We'd say, oh, you'll save a lot of energy. It's not just about thermal comfort, is it? It's also about the view. So once you've externalized all that circulation, you also get these beautiful views, generally beautiful views, so there's a sustainability story. There's also all of the challenge of realizing it relative to the stakeholders, right? A big donor may believe that you're simply not going to get the visitors if they think that there's a discomfort factor to contend with, or I'll say that. And then also, Christian, we were lucky enough. I don't know, lucky. We were supported by a federal grant to do some of the early studies that helped us to support the argument that there was an opportunity here for kind of passively cooling and creating that comfort that we did with a group out of Canada called RWDI that helped us to understand the opportunities around the shaping and whether or not the shaping, it wasn't just about opening up to the exterior, it's about shaping the buildings to kind of optimize for that. But also not creating a wind tunnel where people were like, so I mean, I hope some of that's interesting. There's another piece. I was just looking over a presentation that probably Christian put together for Rensselaer, which is a school up near us up in New York, where we used to be, and it was kind of describing because there's the cast in place element of it, which was important for us, not just because concrete is a big part of making buildings happen in southern Florida, but there was also the issue of the flight path for the airport. So if you're sitting there kind of exploring the universe and you hear a plane flying over, that sucks. And so part of achieving the results here were actually specifying the materiality, the cladding, the insulation, everything, so that you had this immersive experience. And some of that was the actual, the concrete, the precast, all that kind of played a role in that. But I was going to share some of that, but that may be getting into the weeds. But we do have a presentation we put together for that school, Rensselaer, that might be interesting as a follow-up to share. Some of the diagrams and stuff are kind of nice. You might.
For sure. Definitely. If you can maybe share the link in an email or whatever, I'm sure we'll be happy to watch it and see it. I do have a question. I know that you have mentioned, Aaron, that you've been kind of like saying that you guys, I guess, were in the same place when you were designing the project. Because one of the questions that I had was if it was common for the firm to have kind of like the design team in different like cities, or how did that work? But I'm like realizing right now you guys were together.
Right. I mean, as you know, as you said in the introduction, we have offices around the globe, right? On some projects, we, based on either the type of project or maybe this project is relatively large and one office it doesn't have necessarily the right amount of people at that time. So sometimes we split project amongst offices, but normally each project is won and then run and realized out of one of those offices. And Aaron moved to LA a few years ago. I moved to London just last year in October. So for the entire time of us and the other teams working on the project, we were together. We worked out of the New York office. We had consultants in the beginning in New York, but also in Boston. We worked with people in Miami, so there were conference calls, there were video calls already back then. We flew to Miami quite frequently. The client came up a few times over the course of the project. but the core team was at Grimshaw, but also the key consultants in the early design phases were all in New York. So we had a lot of in-person meetings also with the consultants.
Yeah, and it might be worth sharing too that once we moved into, Christian may have to correct me, I believe that once we moved into construction documents, several of our team members went down to work closely with the architect of record, Raguzin Quiroga, stayed in their office and worked side by side with them to make sure that the design intent was carried through to the construction documents. And they stayed for rather extended periods of time, which was, while it's not atypical for the amount of time that they stayed, that, you know, I'm not sure how often we do that. We do it on certain projects.
Yeah. All right, nice. Stephanie, do you have more questions?
Yeah, actually, you guys were talking a lot about like the sustainability. And I know that last year you guys, well, the building received the LEED Gold certificate. So I wanted to know if like the original design plans included all those aspects of sustainability, or what changed to include more aspects to achieve that like LEED Gold certificate.
So the client always had a strong sustainability agenda. Which interestingly enough, in the beginning, wasn't expressed through we want to achieve LEED Gold, but this building needs to feel like it is in and of Miami, right? And the director said, for me, sustainability means you use what is abundant on site. And for her, that was sun, water, and wind, right? So we told already the story about the wind, that we harness the wind, right? That we have more spaces, not only program spaces, but as Aaron said, and I forgot to mention, the entire building circulation in the exterior, right? So we reduce the amount of interior space that needs to be air conditioned, right? Big story, right? Ties into reducing energy consumption, but it starts with you using the wind, right? Water is has multiple aspects. We use, in the end, we collect and store store rainwater. For the aquarium, we use water from the bay, so we don't need to manufacture seawater, salt water, right? Which is in aquaria that are inland, normally done by dumping salt into potable water. Not the most smartest thing to do, right? So we were lucky enough that the water quality in Biscayne Bay was good enough that with just a minimal purification, you can use it for the fish, for the aquarium, for the fish tanks. Sun, right? On the one hand was, okay, you need to shelter yourself off the sun, but also still, right? Though this were just a few spaces, more workspaces, office spaces, right? Use daylight as much as possible in those spaces. Most gallery spaces need to be black boxes. Mm-hmm. But also, right, place PV cells on the roof for energy generation. So these key aspects, or these key drivers, forces on the site that were important for the client to harness, in the end tied into clear engineered systems that then gave us LEED credits. But it sort of was a result of it. It didn't start as the driver, or it didn't start as the goal of it. Do you know which LEED version we submitted under? Was this 2009?
Yes. Well, it could have been 2007 even, but I mean, it probably was 2009. Yeah.
No. Yes, we did the new one. That changed, right? So along the time, along us doing the project, right? And before we sort of nailed, along us doing this, LEED changed, right? It was from, 2007 changed to 2009, and it was then called V9. We decided to, and we did an assessment based with with which system we would have more of a chance to achieve more points, I think. And interestingly enough, the decision was made to go with V9, the new system. The major change between the prior lead version and this version, that now all plug loads need to be counted in your energy calculations. And for an aquarium, the plug loads are through the roof, right? Because all your pumps are considered plug loads, right? They're not part of your core building system. So we used the California Academy of Science by Renzo Piano as a reference project. They also, I think they had achieved LEED Gold or LEED Platinum, but they did this, and they also have an aquarium component. And they still did this with the prior LEED version, so they did not need to consider any of the energy that was needed to run the aquarium. They would have not been able to get such a high LEED certification. So the fact that we received LEED Gold goes to show that we actually did really, really well, in bringing the energy consumption on all the other building components down, because you cannot really bring it down in an aquarium, and then also score as much as possible in the other areas. So along the way, right from the beginning, we had Atelier 10 as a sustainability engineer, who in the end were also the ones who managed to administer the LEED on behalf of the client, did then all the paperwork, and then 2 years later were able to get all the ducks in the row and get the LEED Gold certification. But they accompanied right from the beginning this project and helped us, not only us as Grimshaw, but the entire project, the entire project team, so consultants plus client, to make sure that we fold in early on the key aspects that will give us credits. So most of what in the end we received scores for did get established already by the end of DD, and then sort of properly designed in CDs. As far as I understood, there was in the end also we were a few points shy of platinum. And they did some calcs and figured if they put up more PV cells and would generate more energy online, they might likely be able to get that. But they unfortunately didn't have the money. They tried to raise the money, but they couldn't get it. It would have been easy, right, to just plant more PV cells on the roof, right? Adding a new building system at that point was few months before opening was not possible, would have not been possible, right? So basic answer to your question, most was designed at the right time, right? We started with a strong sustainability idea at the beginning, and that then sort of got ever more detailed, and right, also to a certain point also tailored to the requirements from LEED, of course, right? So by the time we went into CDs and we handed this over to the partner architect, most of this was set and engineered. And you have only minimal opportunities to then later in the game, when you see you may be short, or you realize you don't get points in one category, now you try to achieve them in another category, to still add this, to change the design late in the game. That's normally either very difficult, would take additional time or cost, or sometimes it's even not possible anymore.
Right. So you guys just had to work with
considered early on.
I'll add to that, and this is often considered, of course, at the same time, because they are related, but resilience. So, given the weather conditions in southern Florida relative to hurricanes, and for that matter, flooding where the site is, this was a big issue too, right? I mean, you could spend quite a bit of money and material and effort in designing a museum, which then suffers a rather massive loss of integrity. And that would be a huge sustainability loss as well, right? I mean, we often, as architects, we know that a building which is loved and lasts for many, many years beyond, so it's, a lot of buildings' useful lives, a lot of them are demolished before the end of their material life. I mean, a lot of these buildings are designed to last more than 150 years, but they may only last for 40 or 50. Because the market changes or whatnot, but others are destroyed in big events. And we on this particular site and project were quite aware of those forces, and worked with we think the right engineers to prepare for hurricanes. And a lot of the work that went into the facade design at that living core building and others, had to be managed rather carefully, because these are not systems which you see in other places. And when you see a project like that, you should think to yourself, they went through a lot of hurdles to probably make that happen, because it wasn't an off-the-shelf system there. You could say, look, this will survive this kind of wind event with these kinds of projectiles flying at it.
Already the certificate.
Yeah, it's quite a process. So sustainability, we think about it now more. We need to think about it more. Is also about resilience. We could put a lot of effort into making a very sustainable building that's quite fancy, that just simply won't last, and then we've kind of blown it. So I just add that.
No, I had actually, I know the engineer's not with us, but I had actually had a question for them about like deciding the materials for sustainability and all of that. So that kind of like gave some insight.
You tried to get Ida Albeiser from DDA. So we mentioned that we, as the architects, handed over the documentation after we finished DD to the local architects, the architects of record. And that transition happened from DD to CD. With that transition, also a lot of the consultants changed, because we had sort of our usual suspects, and then the record architect wanted to work with his known consultants. So in the early phases, as the structural engineer, but many other disciplines as well, there was Arup on the team, and then with that transition, DDA came on board. By then, all materials, all the structural systems and the buildings had been decided. So those decisions, the fact that it's a concrete frame building, that lots of the facades are made out of precast concrete panels, that the living core is clad with glazed ceramic tiles. All this was done in sort of developed in SD and then decided and refined in DD.
Okay. And so you said everything was already decided before, so they had already had the idea, because I read that they got the Oculus lens like from Italy, so all of that was already in place with that.
Yes. So yeah. So the windows in tanks, right? They are out of acrylic in all aquaria. They're not glass. I mean, maybe smaller ones can be done in glass, but anything larger than I don't know, 5 by 5 feet is done in acrylic. And any large panels, a large panel is a specialty item. And there are less than a handful companies worldwide that can produce these things. There are 1 or 2 in the US. There are 2 in Japan. There's 1 in Italy. So they are rare. There are really, really specialist companies. So these companies manufacture these acrylic panels for aquaria, but they are also engineering them, right? So the idea of this, well, we should expand on the idea of the Gulfstream tank, the largest tank with its lens a little bit. Because the lens plays sort of a critical role in the success the geometry of the lens plays a role in the success of that tank, right? So it is a museum, right? So it's not just a commercial aquarium. Right? Commercial aquarium, right, operate differently, right? What they want to show, what they want to tell people, in the way how they make money. They work very different than a museum. Most aquaria, proper commercial run aquaria, have much larger tanks, right? So the Science Museum, in comparison to other aquaria, has the tanks are small, right? The largest tank is 500,000 gallons of water. Your standard aquarium has their main tank is 4 million gallons of water, easily, right? No comparison.
Wow.
So right from the beginning, it was clear, right? So we're not building an aquarium here, right? So this is sort of a science version of aquatic habitats, and presenting them should happen through the lens of wonder and of education, right? And it's not about grandness, right? You impress, you pull in the visitors through these other aspects. And the exhibit designer from Think, who are also based in New York, who were engaged by the client, but who we sort of Grimshaw worked hand in hand in the early phases in SD and then DD, had the idea of the tank being sort of like a how would you call an microscope, like an observation tool. Aaron, can you remember what he called this?
No.
No.
Kind of like
sorry.
Kind of like a magnifying glass.
Well, it's sort of Well, it wasn't necessarily about magnification, but it was about this sort of, right? You have a macroscope or a telescope, right? A clearly engineered piece, right? Which allows you to view something in a different way, right? Enlarged, right? Blown up and up close, or zoomed in from far away. So he had the idea that this large tank is something similar, like a special looking device that gives you a view into a world that you normally, right, would not experience. And though, right, in every aquarium, right, they want to create the experience, right? This is sort of this endless body of water, right? But right, and you normally look straight into this tank. You have a vertical window and you look straight into this tank. You always see the back wall. Okay, so I'll continue because Aaron knows all this.
Okay.
Right? So it was so the Gulfstream tank wanted to be something special, right? And overcome the standard problem of your aquarium that you always see the back wall, right? So you, independent of how big the window is, how big the tank is, you see the wall, right? So you sort of, with that you see, okay, you're looking into a confined space. And the species in the tank are from the Gulf Stream, right? And you've probably seen Nemo, right? And it's sort of the highway, right, out in the water, out in the deep ocean of the continental shelf, right? Mm-hmm. So there are species that live there that do never come near a coastline, right? So they don't know boundaries, right? They define themselves only by their distance to the water surface. So the idea was to create the illusion of a boundaryless body of water, right? So how do you do this? By not being able, right, not having the money to build a massive tank. So you do, right? So you do it through ingenuity, right? Through understanding how optics work, right? So, right, if you right, I mean, you see this if you put a pencil in water, right? It seems to bend, right? So the light gets refracted, and technically refracted twice, right? When it goes into the water and when light technically would come out of the water. How much that gets refracted alters with the level of salinity of the water. If you now not only look through a flat glass, but a flat piece of acrylic, but a curved piece of acrylic, that alters that equation, how much this refracts again, right? So this started almost as an engineering formula. Hang on, let me see. Yeah, so he should be dialing in as soon as well. So it started for the exhibit designers as a mathematical, geometrical sort of exercise, right? Roughly understanding how big the tank will be, how deep it is. With that, what is the water pressure, right? So you need, right, in order to resist the water pressure, it's better to do, rather than a flat piece of acrylic, which you would then need to make thicker, right? You curve the piece of acrylic to work better against the water pressure. The more you curve it, the more it gets deformed, it gets refracted, right? So you needed to find the sweet spot of curvature, acrylic, thickness of the acrylic curvature, to still create this effect that when you stand on this mezzanine and you look into this tank that sort of fans out, right, like a very shallow cone, like a martini glass, that you do not see the side walls, right? So that you have the illusion of looking into a boundaryless body of water, right? So this creates an amazing effect, but it's actually a heavily engineered piece, the whole tank and this piece of acrylic, right? And it's based on math, on understanding how light works, how acrylic, how a thickness and a curvature of acrylic piece alters all this, right? So the exhibit designers, again, early on, started to engage specialists, such manufacturers, for acrylic windows. I don't think they talked in the beginning to the Italian company that in the end executed that. But I mean, we do this quite often as well. If we design something special, we reach out to people in the industry that either know how to really engineer this, or they also are able to manufacture that, and they normally engineer this then in-house as well. So before the project was sort of bid, right, the exhibit designers, and we worked with them on the geometry, how the tank gets integrated into the architecture. But the initial idea came from them. And they also worked and had collaborated with specialty engineers for such acrylic pieces to get an rough understanding of, right, of the curvature given the size that we have, the curvature needed, and the thickness given. That then made it into the documentation. That was right into DD, into our documentation, right? So the exhibit designers worked this out. We then documented this in DD. That got then continued into construction documentation. I don't think it got altered much. Mm-hmm. And then this package of all acrylic windows was awarded to this Italian company. They then did the final engineering of this, of all the pieces, including this large piece, manufactured that in Italy, and it was then shipped over, and then sort of craned in. And I don't know if you, Aaron, were there, but I was there for one of these key milestones during construction, which was the craning in of this piece of acrylic. So they had talked to the museum had talked to the American company. They had talked, I think, even to the Japanese company, and in the end, the Italians got it. One of the advantages, so you, in order to assure longevity of these acrylic pieces, right? Because you cannot just go there and repair them easily, right? If there's a crack, if there's something, you need to drain the tanks. It's possible, massive effort, right? So you need to assure that these pieces technically never ever need maintenance or repair or, God forbid, an exchange, right? So in order to achieve that quality, these pieces need to be produced under tightly controlled condition and environment. So this is something that you cannot create somewhere on site, right? You could do this somewhere within a sort of temporary shed, but this is quite cost intensive. So most of these pieces get produced at the manufacturers' companies and then shipped in, right? If you have to ship it, if you have to put it on a truck, bring it down highways, pass underneath bridges, etc., etc., that also starts to limit the sizes, right? Not only what can you do engineering-wise, manufacturing-wise, but how do you get this large piece to site? So the advantage that the Italian company had, they were near Rome, near a port. So there were no obstructions to get from their factory to the port, put it on a ship, get shipped to Miami, right, port city, and then from there on a flatbed in sort of a nighttime action without much traffic, it then got moved from the port to the site. They looked what it would mean to do this from the American company, and I don't know where they were based. I would need to look, but they would have not been able to produce this in their factory and ship it to site in one piece. They had to break it down into 2 or 3 pieces and then set up a temporary tent to sort of recreate their ideal conditions in the factory and fuse them together. And the client didn't want to take the risk and hence went with the Italians.
Wow,
That's actually very interesting because I like that you're kind of telling us all the operations management that has to go into a project, because I feel like a lot of the students don't know how many specialized engineers there need to be and kind of like all the process. And I mean, now that you're saying all these things, it makes sense how the project just took so long, like just so many details that you have to coordinate.
So we had a project directory, right, which lists all the consultants. It was 30 pages long, right? Wow. As an architect, right? Yes, you design the building, you have great ideas, but these type of buildings are engineered marvels, right? They are designed, they're engineered. A lot of specialty knowledge, engineering, consulting needs to go in them. So a lot of those regular but also specialty engineers are on your team, right? The regular architects and engineering team with which you deliver a project. Some are directly hired by the client, so they're not part of your consultant team, but you still coordinate and collaborate with them. And one of the challenges of these projects is, and as an architect, that's one of your key roles, is to coordinate, to mediate also sometimes between different specialties that pull you or the project in very different directions, right? So the greatest idea is nothing if you don't have the right people to make that happen, and if you are able to coordinate this and overcome all the obstacles of engineering, of manufacturing, of cost, of construction, etc., right? In the end, also with an on-site team, construction team, to make such unique projects possible. Hence, yes, they take time and they cost money. Yeah.
And there were a lot of, the aquarium was a huge part of like this project. I had read about like just the concrete pour was a 25-hour continuous pour. I want to know more about like the difficulties that you guys had and if like anything changed in like the design or anything like that during the process because of difficulties.
Aaron, do you know enough about this? Do you want to talk to this?
Well, about the tank itself. that's what we're going to specifically talk about. I don't have as much familiarity with the tank itself and how its design may have been inflected, as Christian will. While Christian's talking about it, if you haven't seen the video of the pour, I can share that, but you've probably seen the video.
I didn't see the video, actually. I just read about it, and I saw like a picture or something.
Yeah, we were there.
About it.
Oh, wow.
Again, we went there. I think you Aaron, you were there for that.
Yes, we were. Yeah, I was there.
Yes. Yeah. And it was definitely one of the most amazing things I've ever seen executed on site.
Yeah.
Right? I mean, at that point, we as the architects, we have nothing to do with that. This is just the construction manager and the concrete contractor.
Oh, okay.
They did several mock-ups. A few mock-ups failed, and at some point, then they did the actual thing. So the reason why this is a single pour is, right, it's a water-holding vessel, right? So it better is waterproof, yeah, right? Watertight, right? It doesn't drip on the visages below, right? So, right, and again, it's not something that you can easily fix or repair in years to come, right? So in order to assure that this is as watertight as possible, right, we went with, and I use a term that the record architect sort of loved using, a belt and suspenders approach, right? You not only use one method that assures you that this concrete bathtub is watertight, but you use several, right? So you use a hydrophobic concrete, you use rebars that are specially coated, that have a special anti-corrosive paint, right? And you do this as a single pour, because normally such tanks, right, concrete tanks, right, their weak point is not, or they don't fail within the wall that got cast in one go, but at the construction joints, right? So the more construction joints, pour joints you have, the more likelihood is that there is a failure. So in order to minimize this or to omit this is to say you have no pour joints and you do a single pour, right? So this was the most you could do with regards to just the construction, the design, the construction of the concrete tank in and of itself, to give it the most longevity and the most assurance that this is done, that this is watertight, right? Of course, it also received a multi-layer waterproofing membrane. It's not just the concrete itself, right? So there's yet, right, that goes to the belt and suspenders approach. There are multiple systems, right? So there can be individual failures or cracks, but that will not cause the tank to leak. What I then understood from the construction team is, so there are single pours that are long, right? Sometimes even 2 days or so, longer than our one was. So the longevity is not the problem. The amount of concrete that got poured in and of itself is impressive, but if you again speak to people, to construction managers that do large scale projects, they have single pours that last much longer. They're much bigger in volume, and right, so much more concrete needs to be pumped. The complexity here was due to the shape, right? Because there was, due to this sort of tilted martini glass shape, there was neither a vertical nor a horizontal surface. So it was very difficult for the people to walk in there, right? Because yes, the pump came down, right? This came from cars and cranes, but you need to have the people that walk on these rebar cages, that pour the concrete, that go in with the vibrators, and in the end that also sort of smoothen out the concrete. This looked like the busiest construction site ever. There were hundreds of people that had to climb up and down on this, right? And so it was difficult, probably also somewhat dangerous for the people to do this. And then, right, because it's on a slope, right, the concrete sort of would technically keep flowing. So in order to assure this long pour, the concrete needs to have a certain, it needs to be relatively liquid, but it can also not be too liquid, because otherwise it would just keep flowing down the slope formwork, right? So there went a lot of thinking on there and into this, right? What is the right concrete mixture? And they did several test runs, test pours to get all these various additives and admixtures right.
Right. It's a difficult process.
So if you're interested in this and hear amazing stories and what the challenges of that were, you should definitely speak to one of the teams who one of the people from the teams who executed this, not the people who designed this.
Yeah. No, I mean, I was just wondering, like, also just about the design of, like, the tank itself, if it had, like, changed, like, at any point in the project.
Yeah.
I think the reason why she's asking this is just because we have the experience that we've had with engineers and architects is we see that architects bring in a design and sometimes the engineer is like, oh no, this doesn't work.
Right, but on every project, even already quite often in the competitions, we team up with structural engineers, with the specialists that we think we need for this project to meet the challenges of this project. So they are on board from the get-go, right? And then there are ideas out there, and the initial ideas normally from us architects are a bit wonky, right? Or need some adjustment to engineer them. But for us, that process to work iteratively, collaboratively with the engineers is what we like, what we feed off, right? This is technically part of our architecture, right? Yes, we have an initial idea for a shape, for something in mind, but it always gets tested and against parameters, criteria, right? And one of them is, of course, how does this thing stand up and hold up, right? How is this structural engineering? And so sometimes it's also just have the ability to listen, right? Not only come with the design and have the engineers change it and work with the engineer, but sometimes the engineer has a great idea, right? And you can pick up on this and develop something different or new. So for many of these aspects, for us, it's also very difficult to say, it's like, oh, this was the idea of the architect, or this was the idea of the exhibit design. Yes, maybe there was an aspect of the planetarium. There was an idea by a single person, by a single company. But the final result is it's after a long process which involved many people, where everyone drives parts of this and informs this, that in the end, this is sort of like the product of multiple ideas, of multiple minds.
Yeah, I will just add to this, because you were interested in how we work differently than maybe some other architecture firms. You know, Grimshaw, coming out of the 80s, was already, you know, a kind of a British high-tech firm, which, if you're not familiar with that designation, it very much is about engaging available technologies to both in terms of building systems and kind of otherwise, though, but it also expressing the integration of those systems in a way that's both architecturally compelling and then kind of appropriate to its program and use. So it's kind of like the idea of the functionalism coming out of the like post-war era, but not necessarily going in the direction of kind of aesthetic minimalism, but engaging kind of a technological, not utopianism, but a technological kind of approach to aesthetics, if you will, that you can actually make beautiful the program, the kind of the systems supporting the architecture, so that when you're in a space, you can read what's happening. It's telling you a story about how things come together, and you can actually celebrate them. So a lot of what Grimshaw have done that we've tried to do, I mean, we would, I think Christian and I would both agree that there are times when we've tried to do this and we haven't always succeeded. But that's my son joining the interview. You know, while we try to do that, and we've tried to do that in many of our projects, and this one would, in some ways, it's a little bit of an exception, but the Gulfstream tank would be an example. We wanted to show as much of the systems supporting and the structural system supporting it as we thought reasonable and appropriate. At some point, it becomes so busy that you have to mute it, right? But I think that when you're talking about how do we work with engineers and are we trained engineers, of course, so we're not, you know that now. But when we do work with our engineers, they know that we do typically try to work with a handful, right? Be it Arup or Buro-Happold or Thornton Tomasetti. There's a handful that we like to work with, and one reason why we like to work with them is because they know how we like to work. They've worked with us enough so that we don't go over the same material over and over again. But they also know that they may need to provide us a contract for the work a little differently than they would to some others, right? They know that we're going to be exploring more than a handful of solutions sometimes to a certain condition, and that they'll need to spend a little more time with us on certain things. So that's
but that we also bring them to the table.
Yes.
Right.
Oh, awesome. Stephanie, do you have one more question or?
I think I've mostly asked like everything. I just had like one last question, like I guess for both of you, about what your favorite aspects of the museum are, because we talked about like big aspects, but we also didn't, there's little aspects that we might not know about. And I know we didn't talk about, I read that you guys added this geometric shape on the walls to have kind of like an effect with the sun. So what's your favorite aspects of the museum?
You first, Aaron.
Oh gosh. I actually did read that question and I was hoping Christian was going to go first.
You want me to go first?
Well, yeah, if you have one, because I still have to think of mine.
Okay, then let me go first. I mean, as Aaron said, right, both of us worked on this project quite long, right? So these projects almost become like your child, right? Which you nurture over many, many years, where you form great relationships. So boiling all this down to just one thing almost does a disservice then to so many other things, right? But for me, it is linked to one of the things that we talked about with the wind, with these exterior spaces, and creating visitor comfort in these large amount of exterior spaces, right? It sort of defies convention, right? And Aaron even said, right, maybe not everyone likes spending that much time in the outside. Yes, they feel the breeze, it's sort of comfortable, but it's still not air conditioned, right? And ever since the emergence of air conditioner, they are ever so present everywhere in Miami, in South Florida, right, in Miami. It makes the life possible there. Everyone now thinks it doesn't go without, right? So here we try to sort of challenge this, rattle the cage a little bit, right? Technically go back to times pre-air conditioning, right? I mean, we still, of course, have a museum that has spaces that need to be tight and have tight environmental control. So we can't get around air conditioning some of it, but we minimized it, right? And we tested this, again, Aaron mentioned with the grant from the DOE in the beginning through computer simulations, but even through a wind tunnel test, right? A lot of thinking, a lot of work and exploration, right? Then on the day of the opening, right, we went there, right? They set up the sort of the ribbon cutting outside of the courtyard, right? It was May, right? Already pretty hot, right? Everyone came in their best in suits and ties, right? And then all the important people, politicians, donors gave speeches, and everyone was just sweating and wishing this would be over and the ribbon would be cut, right? So we are exposed in the sun, right? You barely feel the breeze that is coming in from the ocean because the sun is so hot.
Yeah, no, it's so hot here.
The ribbon gets cut, right? Everyone walks into this shady courtyard, and within 5 minutes, your body cooled down. And seeing these years of thinking and testing that quickly at work, and seeing that everyone is just like, oh, right, noticing and enjoying it, and enjoying that the fact that it's not only interior spaces with great exhibits, but you have these comfortable, great exterior spaces where you have views out to Miami, out into the bay, right? To clearly say this museum is in and of Miami, right? The context of Miami is much part of the museum as the aquarium, as the galleries itself. And standing there as the architect and having people walk by that don't know that you're the architect and sort of commenting on these things, that's one of the best things that you then can take away after years of working on this project, right? That this one of these key ideas, physically works, and people really enjoy it, and keep apparently also saying that that's one of the best things on the museum, right? You have the interior spaces, but you can get back out. You can sort of, this also helps to overcome museum fatigue, right? If you spend hours within a darkened space inside within the same conditioned environment, right? If you constantly re-engage the exterior, right? Different light levels, right? Your eye can wander to the distance, right? So many benefits are achieved by that. But the mere fact that people just simply enjoy this and enjoy being at this museum, not just for the exhibits itself, that's for me one of the greatest things of this building.
Yeah, it's very amazing how different it is from like a typical museum, because especially like seeing that you can see all floors and you can see like a bunch of different things from like one spot, as opposed to being like just in one set path as you're going throughout. It's very nice.
Aaron, did I talk enough and give you enough time to think about one?
Yes. I guess I'm going to share my screen. So you can see this. I think you can see what is the kind of the wind kind of test in the lower left corner, right?
Yeah.
Okay. Yeah.
The model that the company that I was describing that helped us to define what level of success we should achieve by the sculpting of these buildings, right? So you can see in the you can see the analyses above, and then the wind tunnel model that they built in order to do some of that testing. And we can share some of this if you'd like. But this is not my favorite thing, because Christian already spoke of it. Although it could have been my favorite thing if he hadn't said it. So
you're allowed to have the same favorite.
And you know, I was lucky enough to bring my son there. I think not too many months after Christian and I were there for the opening, so I got to see him also enjoy the exhibitry. So that was really enjoyable. Now I'll say this, that I'll choose, as Christian said, we could choose any, but I'll choose one that Christian and I had to work very closely together on to achieve this success, and it's the living Chord tile facade. And I'll say that because it was a great challenge, and maybe it was one of our greatest concerns going forward as the architects, that we had proposed a facade and a system which was basically unprecedented. And the manufacturing of that tile proved to be a great challenge. But never mind that. Once we kind of got over that hurdle, then it became, okay, but who's going to build it? Who's going to be responsible for building it? And who's getting it across the line ultimately? And I'm going to spare you all that drama, because that was just too much. But I will tell you this: it was a great feeling to see it go from an idea. And I can remember the moment when Christian turned to me and was like, let's do a flat, a concave, and a convex tile, that's about this way. And then let's start printing little versions of it. We're going to test
3D printed. So we 3D printed this in-house in our office.
Yeah, and so building off of this idea, then looking out for various manufacturers, which wasn't as easy as you think. There are plenty of manufacturers out there, but they don't all want to do a custom tile of this size. Even though the living core is quite large, it's not enough for a massive industrial plant to kind of retool for, right? So you were looking for somebody who's not just artisan, but somebody. So in our case, we found someone in upstate New York who had never created architectural tile before, but was used to creating high voltage, so really utility type products.
Insulators.
So went up to that plant. They showed us a tour. They were gonna work with this artisan who got to know. So it's a long story again, but it shows how one kind of architect's kind of concept begins to get realized through a process, which I think ultimately is one of the great successes of the Science Museum. And just to say that, like, all of the design that went into and all of the conversations that in the emails that would have flown between engineers, waterproofing experts, tile specialists, installers, talking about how much, is our cost estimation for the installation correct? There are so many, and then all the various mock-ups that we went through around grout color, percentage of convex, concave, a lot of work there. And then ultimately putting it up for a mock-up for testing against hurricane projectiles. Are the tiles going to fly off and injure individuals in the event of a hurricane? That was an intriguing part of the process. And then being aware of contingencies all along the way. Like, if in fact this doesn't go well, what's our backup? You need to think about that before we go down this path with you. So contingency planning. And architects are, our contracts are written such that when we go down these paths of being innovative, we also bear a lot of the costs that are of that as well, and we have to have good partners then as clients, is what I'm saying. So in our case, we had a great partner that the client was willing to go down this journey with us, and what's great is that we felt like we were able to give them a wonderful kind of result here. And if you've been to the museum, but I think that facade is very special, and I guess I'm very happy it turned out as well as it did. Knowing all the drama, it's also just such a relief to know that it was a success. So.
No, it's very interesting, and I actually had gone to it I've only been once in June of 2017, so like right when it opened, and I haven't been back since. And at the time, I wasn't an engineering student, but I want to go back and see it differently now.
Yeah,
yeah, definitely do that.
Well, those were great answers. They were both very amazing. And I want to congratulate both of you and just your entire team, because this is such a special structure, so unique here in Miami. And just the fact that you were just trying to minimize the use of AC, which, like you said, Christian, I would think it's impossible to live here without AC just because it's so hot. But I just feel like it's very impressive. It's very not only insightful, but very inspiring. So I want to congratulate you. I want to say thank you. The interview has come to an end. I'm so sorry it took more than an hour. I'm so sorry it hung up by itself. I don't know can we say goodbye to your son, Aaron? And I don't know, you have a little baby with you a second ago.
He just wanted to bomb our call. That's all. That's what he gets his kicks out of.
So cute. But if you guys are ever in town, if you're ever in Miami, I know Stephanie and I would love to just buy you a Starbucks, kind of like chat a little bit, because you guys have just created such amazing designs, and just really thank you so much for everything you've done for us today.
Oh, you're welcome.
Yeah, you're very welcome. Anytime.
Thank you.
And the funny thing is, over the years, we've done a few interviews, and it never lasts. We never managed to do this in an hour, because the building is quite diverse, right? It has quite a few different aspects or design ideas. But it's also a little bit of a cornucopia, right? It has a lot of unique stories, right? It not only has this unique story about the tile facade and the aquarium, then there's the planetarium, and then even other things, right? So it has way more components or aspects than your regular building. So And then people normally want to, of course, know everything. So it always takes more than an hour.
Oh,
Yeah,
thank you
I mean,
so
there's a
much.
lot.
Good.
Wonderful.
So yeah, thank you so much for being a part of this initiative. And yeah, thank you so much.
Well,
I hope you guys are safe. Everybody be safe.
Yes, stay safe and healthy. Indeed.
You too, guys. We'll talk soon, okay? Thank you
Take
so
care.
much.
sounds good.
Bye.
Bye.
Bye.